Okay, today we're going to talk about pyramids, and like I said before, you're going to, all these vocabularies for pyramids are really similar to the one for prisms. So it's really similar. So here, pyramids, there you go. You know what pyramids are, right? How are these pyramids different than prisms? Obvious. There's some of the obvious reasons, some of the obvious things. Yes, Austin?
They only have one base.
Yeah, they only have one base. Secondly, what about the lateral face?
Oh,
Yes, sir.
they're triangles?
They're triangles, okay? Whereas prisms, they are rectangles, right? Or like parallelogram if you're in oblique and so forth. Okay, so we got a pyramid V, A, B, C here. And you got a vertex V on top, okay? Pretty much similar. And then you got the base, A, B, C, D, E, okay? So this diagram on the right, we got a pyramid V, A, B, C, D, E, okay? And how is this one on top and the one on the bottom different? Yes, sir. Kevin?
One's oblique and the one's,
Okay, yeah. This one looks like it's an oblique, kind of, right? The other one is a right. Also, Jet. Sure, bottom one has 6 sides and top one has 5. Anything else? How about, yeah, weird.
The bottom one has a regular base and the top one doesn't.
Correct. The bottom one has a regular base, right? So, Brianna, in this regular hexagonal pyramid, right? Do you see the height of this pyramid? With H. And guess what? This height, guys, is going, if you from the vertex, for a regular pyramid, if you go from the vertex of this pyramid to the base of this pyramid, it's going to meet at O. O is going to be the center of this base. Is that okay? And it's going to be perpendicular, exactly. So I'm going to show you some of the, okay, we have that altitude of these, okay? And look at the lateral faces. Didn't we say the lateral faces are triangles and so forth? And we got the lateral edges, right? This is very similar to prisms. And now I want to show you some things about regular hexagonal pyramid. There are 4 properties that you should be aware of. First one, the base, of course, is a regular polygon.
Rewrite these down.
If you like, yeah, but you know, yeah, for these regular pyramids, you should write this down. So let's write down some of the, because all the other ones are pretty straightforward, right? The vocabularies. The base is a regular polygon. Secondly, do you see my lateral edges? They're all congruent. If it's a regular hexagonal, if it's a regular pyramid. Thirdly, the lateral faces are congruent isosceles triangle. And in this congruent isosceles triangle, do you see how we have a height of this lateral face? That height is called the slant height. And we use L for that. And fourthly, of course, the altitude meets at the base at its center O. In other words, from the vertex to the center of the pyramid, it's going to be perpendicular segment, which is going to be the altitude. So go ahead and write it down. I'll wait for you. What do you guys think about this slant height? What do you think we even need the slant height? When do you think it's going to be useful for? Anybody any guess? Why don't we just talk about the height of this pyramid? Why do you think we even need to sort of... By the way, the reason for slant height, it's obvious that we don't want to use H for slant height, right? Because then it would be kind of confusing. What do you think we need a slant height for? Yes, sir?
Find the
Area of the what?
lateral area.
Yeah, to find the lateral area, that's what you're going to need. Right? You're not going to really need the height. Well, actually you do, sort of, because depending on what kind of question they give you. So here's, take a look at this question. Let's look at the example. Our first example says this. A regular square pyramid has base edge 10 and lateral edge 13. It says find the slant height and the height of this regular square pyramid. And do you think it's a good idea to draw what this is? And let me show you how to draw a pyramid. Okay, it's kind of easy. So first, let me show you. Hold on. Here we go. So the trick is, in drawing a pyramid, we know that the base is a square, but obviously you're trying to draw a 3-dimensional figure in a 2-dimensional space, right? So you can't really just draw a square here. So what you're going to do is you're going to draw a parallelogram. So you do this, and use the you know. I know. So why do you think I drew a parallelogram just now? Yeah, because you're trying to fit a three-dimensional figure into a two-dimensional space, right? So that you have to. That's what I just said. So and then you go from the very center of this parallelogram, go up and put a dot. Guess what that's going to be? Yeah, and then you connect the corresponding. This one I'm going to put a dotted line like this because it's in. It looks like it's. Oops. Looks like it's behind it. There you go. Oops. And if you use a ruler, it's much better. If you have it, there you go. And if you can't, you could actually erase some of these marks too in the back, so it looks like it's dotted. Then it helps you sort of see, right? Those are behind the things in front. There you go. So that's how you draw a pyramid like that. Okay. So if it's a square pyramid, I know that base is square, but you got to draw a parallelogram to kind of fit that in a two-dimensional space. Okay. Exactly. And now it says has base edge 10. Which one are they talking about when they say base edge is 10? Yeah, so right here. Oops. You're exactly right. So from here to here is 10. What about from here to here? Well, and of course, all the other side, right? It's a square, right? And what is the lateral edge 13? Where's that going to be? Yeah, size of the triangle is 13. That's what they're saying. Okay, so you have to understand what they mean. They don't give you these pictures, so you have to figure out, right? Of course, all the four lateral sides will be 13. Okay, lateral edges, I mean. All right, and so what do they want you to find? Slant height. So is the slant height the height of this pyramid or the height of the lateral face? Good. So I'm going to draw it like this. There's my, and what kind of angle would this make? All right, so I'm going to call it, which letter do we use this for? L. And of course, let me do this in different color. Height is going to go down here, make 90 degrees. And it's going to be this in the center of this square, isn't that right? Because you have a regular point. And this is going to be H. All right, go ahead. Everybody find height and then the slant height. I'll wait for you. Go ahead. Everybody try. So here's a better picture of it. A little better. Okay, now let's find the slant height. To find the slant height, which triangle, which right triangle, I should say, which right triangle should I use? How about, you ready? Kristen, which right triangle should I use to find the slant height? Exactly, one of the lateral sides, right? So, namely VMC or something like that, right? So L is going to be, so which equation should I use to find L? Use the Pythagorean theorem, isn't that right? So it's going to be L squared plus what? By the way, how do I know this is 5? Yes, half of the, yeah, it's an isosceles triangle and then you cut it in half, right? The altitude is going to meet at the midpoint of the side. So here, L squared plus 5 squared is equal to 13 squared. When you solve, how many people got? 12. That's the answer. Very good. If you didn't, do you see why it's 12?
Yes.
Okay, once you know then the slant height is 12, now you can find height because what is the length of OM from the center to the midpoint of this? Yeah, it's going to be 5 because the whole thing is 10. You know this is going to be right in the center, right, of this square. So we need to use again the Pythagorean theorem. H squared plus 5 squared is equal to L squared, which is 12 squared, 144. So then when you solve, did anybody get the answer? What did you get? How 2 people got it?
Me.
Okay, I'll wait. Go ahead. What did you guys get? What did you get? Should the answer? All right, the answer should be square root of 119. How many people got square root of 119? Very good. Okay, because you get another right triangle over here, right? VOM. Easy enough?
Yeah.
All right. So once I have this, then we're gonna ask you to find the lateral area. So how would you find? So this is example 2. How would you find the lateral area of this regular square pyramid? Okay, how about Josh?
Say again, the perimeter of the base.
If you
Almost. Slant height.
not quite, almost. So okay, I know that some of you. Okay, so first of all, alright, hold on. Could we just find the area of the lateral face? And how many of those do you have? You have 6 of those? You have 4 of them, right? So go ahead, everybody find the area of the lateral face, one of them, and multiply that by 4. That's the answer. Go ahead, I'll wait. Go ahead, everybody try. So here, isn't that the lateral face? The dimension is 10 by 13 by 13. It's an isosceles triangle. We just found the height of this face, right? Lateral face is 12, right? Slant height. So of course the area of this triangle is 60, not 120. Some of you forgot to divide it by 2. Right, it's 60. And how many of these do we have? 4. So of course the answer is 240, right? Units squared. Okay. Easy enough? Now some of you mentioned perimeter. It turns out you're right. There is a shortcut of doing it this way. The shortcut is, how about, what do you think the shortcut might be? It's kind of similar to the one we did with the prism. How about Andrew?
Find the perimeter of the base
Uh-huh.
times the slant.
Not quite. If you, divided by 2 is correct. So here is the theorem. It turns out when you have a regular pyramid, the lateral area of a regular pyramid equals to half the perimeter of the base times the slant height. By the way, could we have done it the way we just did it? Just find one of the lateral face and multiply by how many of them you have? Yeah, same thing. But let's see how they got this. And again, this is very similar to the way we found the lateral area for a prism. What was it? P times? P times H. P times H for the prism. But now here, this lateral area for the regular pyramid is half times P times L, not H, L, okay? The slant height. So let's think about why this might be true. As you write this down, think about it, okay? So why do you think we get this formula? Okay, let me show you this picture, by the way. Here, this picture represents regular pyramid with n size. And how do I know this is n size? Because I have these arrows. And what does B represent? Yeah, that's the length of each of the size of the base, exactly. So, and because it's a regular, because you know there's a regular pyramid, right? There are how many B's do we have on the bottom? N of them. We say n. Okay, so where do we get half P the perimeter times the slant height? Well, let's first of all write this down using the method we just did by finding the area of the one of the face, lateral face, and then multiply by n. Wouldn't they give you the lateral face? Right? I mean lateral area. Yeah. In other words, can I just find the area of this triangle and multiply by n? Would that give you the answer? Okay. So what is the area of one of the face?
1/2 BL.
1/2 BL. Okay. So that's what we have right here. How many of these do we have?
N.
We have n of these because it's regular n-gon as a base, right? Well, let me take a look at this real quickly. What's B times n? Yeah, and what is that equal to? Perimeter. So isn't that same thing as half times PL? Okay, so it's very simple. It's kind of similar to the way we did for prisms, right? Because if you were to multiply n times p, isn't that the perimeter? Okay. Notice, do we need the height of this prism at all? No, we actually need the slant height, right? Of course, height could help us to find the slant height, just like the previous example. But we need the we need the slant height. Okay, does this make sense? Okay, so that's how you go about showing why this theorem is half PL. Okay. Any question? Okay, does this make sense? All right, good. Now what we're going to do is we're going to compare. We're going to talk about volumes. Okay, do you guys remember how to find the volume of this one of the prism? Yeah, it is the area, not base times height, but area of the base. Remember which letter do we use for area of the base? Thank you. Capital B times H. Now, it turns out to find the volume of a prism, let's just look at this prism. They both have the same base. That's why they're same color. Okay, in other words, if they have the same base, the area, if they have the same congruent base, okay, and the same height, which one has more volume, first of all? Yeah, the first one, of course, prism. But how many more would the prism have in terms of? How many people say 2? The prism is going to be twice as much big as the. Okay, how many people say something else? Any other guesses? Yes, sir. 3 times. How many people say 3 times? How many times say 4 times? This will be good. Okay, well, I have a nice sort of way to show this. Okay, let's take a look at this. Hold on. So take a look at what I have, guys. I have, what do you see?
Two shapes. A prism
Okay.
and a pyramid.
There you go. So look, if I do this, you could kind of see it better, right? So one of them is a prism, the other is a pyramid, okay? Now, they both have the same base. Like, I could actually put this on top of this. You can see they have the same base. And if you do this, it turns out, I don't know, it's kind of hard to see, but they both have same height, okay? So to show you or to compare the volume, what I'm going to do is I'm going to fill this pyramid with water and pour it in here. And see how many times it'll fit, okay? All right, so let me do that. Huh? Yeah, we did that last time too, exactly. So some of you saw it. Yeah, yeah, here we go. So, I know that I have to be really careful when I do this. Here we go. I'm going to do my best. Okay, I'm just pouring water in here. I'm just pouring. Alright, fine. Okay, so obviously it's kind of hard to be really accurate, but I'm gonna just do my best. I'm gonna open this up so I can pour it in. Here we go. Let me pour this in. Oops. Okay. Open this now. Pour it in. Okay. I bet by this time you could. Okay. How much do you think has?
1/3.
Okay. It turns out you're right. It fits exactly 3 times. So let me actually pour in more. Okay. It turns out it's exactly 3 times. All right. Here we go. So let me pour it in the second time. Open it up. Hey, look. Right, so it's going to, I'm going to fill in the last bit now. Yeah, so some of you saw this in summer school, right? I did this. Okay, here we go. Pour it in. There you go.
That's 3. It's not exact. Oh, you just, oh, now it's exact.
There you go. Okay. Do you see how it fits exactly 3? Right?
Yeah.
So, all right. Thank you, thank you. All right, now what if I did it for this one right here? What if I did it for, let's see. Yeah, I did have. Okay, so what if I did it for this cube versus this triangular pyramid? I mean, not triangular, rectangular pyramid?
4 times.
No, it's going to be, again, 3 times. It's always going to be 3 times as much. If they have the same what? Base and the same height. So now that helps us to get this theorem. Look at this theorem. It says what? Volume of a pyramid is what? 1/3 of the base times the height. Because what is base times height? That gives you the volume of a prism, right? So it's 1/3 of it. The prism, of course, that has the same base and same height. Does that make sense?
Just accept it like that, or is there a reason?
Okay, so I just showed it to you with this experiment, but it turns out there's a way to, prove it and so forth. But right now we're just going to use this theorem. Is that okay? So it turns out that the volume of a pyramid is 1/3 the area of the base times height, which is the area of the, volume of the prism, right? That has the same base and same height. Does that make sense? Okay, so write that down, and you're going to need this for your homework tonight, okay? So let me, in order to do your homework tonight, guys, you need this information. Please pay attention for this. Okay, so if I have a triangle, and we haven't learned this yet, so I'm just going to give it to you as a fact. We're going to, in chapter 14, in chapter 14, so in chapter 14, we're going to prove this. But right now, I'm going to give you as a fact. Please write this down, because you need this for your homework tonight, all right? So if I have a triangle, any triangle, okay? If I were to, let's say this is the midpoint of this side right here. This is the midpoint. And this is the midpoint of this side. If I were to connect all these midpoints, these are called the medians of the triangle. Yeah, it's going to meet at one point right here. Okay? So that's not the important part. But they do meet at that point, but not only that, if the length from here to here is A, guess what this is? No, it's twice as much. It's twice as longer. This is a fact. Okay, I'm just telling you. And then if this is, of course, B, guess what this is? Yeah. And then if this is C right here, guess what this is? Okay. This is always going to be true. If you were to connect the medians of a triangle, right, it's going to meet at a point, and the distance between the small pieces to this is twice as long. This is always true. Okay. Yeah. So this is going to be true for any triangle. Okay. They're going to meet at the point, And of course, when you do your homework tonight, it's going to, the base of this pyramid is going to be what kind of triangle? What kind of triangle? It's going to be equilateral, because we want it to be regular. Now, I'm not done here. So if you get, you guys listen. So if you get a picture like this, you have an equilateral triangle underneath. You see this O? You see AM, this M is the midpoint of BC, okay? This O, right? What is the distance between OM? What's the difference? Yeah, if OM is A, what's OA? 2A. Does that make, and this B and O, because O is the center of the circle also, right? It's going to be, this is going to be your altitude. Does that make sense? Yeah, so please, guys, I'm not done. Please. So please note that O is at the center of this circle, and V and O, that's going to be the altitude. It's going to go right in the center of this circle. It's going to be perpendicular. Okay? And, right, and also please, if you have time, please, before you do your homework, look at example 2 and 3 before you do your homework tonight. Because we didn't have time to go through those, okay? I mean, 3 and 4. Look at example 3 and 4. Did you all hear me?
Yeah.
Before, otherwise, you're not going to be able to do this. Okay, all right, very good.